Hi, Doc.
Welcome. So good to have you here. Dr. Clayton, I can't wait.
The background has been carved down just a very little bit. This isn't entirely three-dimensional, and you see that Donatello has tried to give it a sense of space by barely incising some lines perspectively to give a sense of setting.
That's
But it's
interesting.
very active, and you see this woman standing here observing it, and she's in this perfect classicizing.
It's all right. No.
I look forward to learning.
In that case, let me get, as the name implies, our most, to that end, we've even started to explore the idea of synthetic animal life. You probably saw the gorillas. They're really just a pet project at this point, but the potential is exciting nonetheless.
Seems like there's nothing you can.
With hard work and ingenuity, and I'm sure I've taken up enough of your time as it is.
I'm not sure how well I'll fit in, but I'd.
Great. In any case, I imagine.
You mentioned medical care. I might need that from time to time.
In that case, you'll want to. He's our top bio. Dr. Volker, you won't find.
Dr. Holdren's synth gorilla project is showing promising results. You're here. Glad you made it.
So directly across from this weighted leg is the arm that's doing some kind of work. So here it's holding a book, because again, Marcus is an evangelist. And then that free leg is right across from the free arms. This will X balance into the sculpture. One of my favorite details of the sculpture, though, is if you look at that weighted leg really closely, and you look at the way the drapery is falling across the body, perhaps more naturalistically than the St. John that's done in a more international Gothic style. The folds of the drapery almost look like a classical fluted column. So it's like he's pulling this architectural element, this very distinctly Romanizing architectural feature, and putting it right on display in the old Florence. So with Orson Michele, you can see the changing style of art. So Ghiberti does a number of other sculptures for Orson Michele that I'm not showing you here, but they're done very much in an elegant international Gothic style. This would have been directly juxtaposed with Donatello's far more classicizing approach to the human figure. Donatello also pays very careful attention to the action of the drapery with the body. It informs very much how the clothing falls. So, in fact, it's like he drapes clothing around a new form, rather than patterning the drapery however he sees fit, how it might look nice. The body really does seem to form what's happening with the clothing. It's a complete move away from the medieval treatment of Dutch sculpture. Now, the Linaiuoli was not as powerful and wealthy a guild as somebody like the Kalimala, remember that's the Wool Weavers Guild. Their sculpture here was of St. John the Baptist, completed by Ghiberti, and it's done.
Yes.
So they're showing their wealth, and by hiring a more famous sculptor, they're also showing their prestige. But the Linaiuoli are using a lesser material and a less well-known sculptor, even though today Donatello is far more famous. In 1411, that's one of the things that means, though, is that Donatello actually had more freedom to be innovative than Ghiberti did. If you're working for a more powerful guild, that means they're going to have higher demands, whereas Donatello, with a lesser guild, could do a bit more without stepping on Ghiberti's gallery, and this was made for the interior of the Duomo in the 1430s. This was one of two singing galleries produced at this time. Here's an image of the second one. This one's by Luca della Robbia, and these were terracotta and in maiolica. So he's a sculptor of a sort, but typically he doesn't work on quite this large of a scale. What we see in Della Robbia's work is very classicizing relief sculpture and very much imitating Roman sarcophagi. The subject that we see here is an illustration of song.
What must natural selection, working for billions of years, be capable of? The answer is all the beauty and diversity in the biological world. vegetables, but also from the record in the rocks.
That's it.
Some of that speaks to us unambiguous creatures that were once present in enormous numbers and that have now vanished utterly. There are far more species that have become extinct than exist today. They're the terminated experiments in evolution. These guys, for example, the trilobites, appeared 600 million years ago. They were around for 300 million years. They're all gone. There's none left. But in those old rocks, there are no fossils of people, cattle. We've evolved only recently. Evolution is a fact, not a theory. It really happened. Natural selection was the great discovery of Charles Darwin and Alfred Russel Wallace. Here's how it works. Nature is prolific. There are many more creatures that are born than can possibly survive. So those varieties which are, by accident, less well adapted, don't survive. Or at least they leave fewer offspring. Now, mutations, sudden changes in heredity, are passed on. They breed true. The environment selects those occasional mutations which enhance survival. And the resulting series of slow changes in the nature of living beings is the origin of new species. Well, many people were scandalized by the ideas of evolution and natural selection.
Yes.
Our ancestors looked at the intricacy and beauty of life and saw evidence for a great designer. The simplest organism is a far more complex machine than the finest pocket watch. And yet, pocket watches don't spontaneously self-assemble or evolve in slow stages on their own from, say, grandfather clocks. A watch implies a watchmaker. So, there seemed to be no way in which atoms could spontaneously fall together and create, say, a dandelion. The idea of a designer is an appealing and altogether human explanation of the biological world. But as Darwin and Wallace showed, there's another way, equally human and far more compelling. Natural selection, which makes the music of life more beautiful as the eons pass.
I'm in.
To understand the passage of the eons, we've compressed all of time into a single cosmic year with the Big Bang on January 1st. Every month here represents a little over 1 billion years. The Earth didn't form until the cosmic year was 2/3 over. Our understanding of the history of life is very recent, occupying only the last few seconds of December 31st, that small white spot at bottom right in the cosmic calendar. What happened on Earth may be more or less typical of the evolution of life on many worlds, but in its details, the story of life on Earth is probably unique in all the Milky Way galaxy. The secrets of evolution are time and death. Time for the slow accumulation of favorable mutations, and death to make room for new species. Life on Earth arose in September of the cosmic calendar, when our world, still heavily battered and cratered from its violent origin, may have looked a little like the moon. The Earth
Scanners detecting
is about
sentient
4.5
life.
billion years old.
Alert level elevated.
Out of interstellar gas and dust.
God damn it. Thank you, Assaultron.
Anything so complex as a one-celled organism, which already is a highly sophisticated form of life.
I need my
The first
45.
stirrings of life were much more humble and happened on the molecular level.
Fuck
In those
this.
early days, lightning and ultraviolet light from the sun were breaking apart simple hydrogen-rich molecules in the primitive atmosphere, and fragments of the molecules were spontaneously recombining into more and more complex molecules. The products of this early chemistry dissolved in the ocean. Organic soup of gradually increasing complexity. Until one day, quite by accident, a molecule arose which was able to make crude copies of itself, using as building blocks the other molecules in the soup. This was the ancestor of DNA, the master molecule of life on Earth. It's made of 4 different molecular parts called nucleotides, which constitute the 4 letters of the
Nice.
code, the language of heredity. Each of the 4 nucleotides, the rungs on the DNA ladder, are a different color in this model. The instructions that are spelled out are different for different organisms. That's why organisms are different. Now, a mutation is a change of a nucleotide, a misspelling of the genetic instructions. Most mutations spell genetic nonsense, as you'd expect, because they're random. They're harmful for the next generation. But a very few, by accident, make better sense than the original instructions and aid the evolution of life. DNA is about 1 billion times smaller than we see it here. In fact, each of these things that looks like a piece of fruit is an atom. Without the tools of science, the machinery of life would be invisible. For billions of years, the ancestors of DNA were repeating molecular building blocks, leaving crude copies of themselves. There were no predators, the stuff of pools that filled the craters.
I hate the Sultrons.
The evolution of living molecules was well underway. Varieties with specialized functions then joined together, making a collective, the first cell. The organic soup eventually ate itself up. But by this time, plants had evolved, able to use sunlight to make their own building blocks. They turned the waters green. A number of plants joined together, the first multicellular organisms. Equally important was the
Bitch.
invention
Blow up.
It was stumbled upon by
Fucking hate the Sultrons.
By December 1st, green plants had released copious amounts of oxygen and nitrogen into the atmosphere. The sky is made by life. Then, suddenly, on December 15th, there was an enormous proliferation of new life forms, an event called the Cambrian explosion. We know from the fossil record that life arose shortly after the formation of the Earth, suggesting that the origin of life might be an inevitable chemical process on countless Earth-like planets throughout the cosmos. But on the Earth, in nearly 4 billion years, life advanced no further than algae. So maybe more complex forms of life are harder to evolve, harder even than the origin of life itself. If this is right, the planets of the galaxy might be filled with microorganisms, but big beasts and vegetables and thinking beings might be comparatively rare. By December 18th, there were vast herds of trilobites foraging on the ocean bottom, and squid-like creatures with their multicolored shells were everywhere. We know enough to sketch in a few of the subsequent details. The first fish and the first vertebrates appeared on December 19th. Plants began to colonize the land on December 20th. The first winged insects fluttered by on December 22nd. And on this date also, there were the first amphibians, creatures something like the lungfish, able to survive both on land and in water. Our direct ancestors were now leaving the oceans behind. The first trees and the first reptiles evolved on December 23rd. 2 amazing evolutionary developments. Weird to descended from some of those reptiles. The dinosaurs appeared on Christmas Eve. There were many different kinds of dinosaurs. The Earth was once their planet. Many stood upright and had some fair intelligence. Great lizards crashed and thundered through the steaming jungles. Unnoticed by the dinosaurs, a new creature, whose young were born alive and helpless, was making its timid debut. The first mammals emerged on December 26th, the first birds on the following day. But the dinosaurs still dominated the planet. Then, suddenly, without warning, all over the planet at once, the dinosaurs died. The cause is unknown, but the lesson is clear. Even 160 million years on a planet is no guarantee of survival. The dinosaurs perished around the time of the first flower. On December 30th, the first creatures who looked even a little bit human evolved, accompanied by a spectacular increase in the size of their brains. And then, on the evening of the last day of the last month, only a few million years ago, the first true humans took their place on the cosmic calendar. The written record of human history occupies only the last 10 seconds of the cosmic year. Now, let's take a closer
Got
look
it.
at who our ancestors were. A simple chemical circumstance led to one of the great moments in the history of our planet. There were many kinds of molecules in the primordial soup. Some were attracted to water on one side and repelled by it on the other. This drove them together into a tiny enclosed spherical shell, like a soap bubble, which protected the interior. Within the bubble, the ancestors of DNA found a home, and the first cell arose. It took hundreds of millions of years for tiny plants to evolve, giving off oxygen. But that branch
The first dead cat I've seen in the whole game.
Bacteria that could breathe oxygen took over 1 billion more years to evolve.
Oh my god, it sticks its tongue out when it dies.
From a naked nucleus, a cell developed with a nucleus inside. Some of these colonies with inside and outside cells, becoming a polyp attached to the ocean floor, filtering food from the water
Nice.
and evolving little tentacles to direct food into a primitive mouth. This humble ancestor of ours also led to spiny-skinned, armored animals with internal organs, including our cousin, the starfish. But we don't come from starfish. About 550 million years ago, filter feeders evolved gill slits, which were more efficient at straining food particles from the water. One evolutionary branch led to acorn worms. Another led to a creature which swam freely in the larval stage, but as an adult was still firmly anchored to the ocean floor. Some became living hollow tubes, but others retained the larval forms
Leave that cat in the middle of the
and became
ring like
free-swimming
that,
adults
so
with
wrong.
something like a backbone. Our ancestors now, 500 million years ago, were jawless, filter-feeding fish, a little like lampreys. Gradually, those tiny fish evolved eyes and jaws.
Sweet.
The fish then began to eat one another. If you could swim fast, you survived. If you had jaws to eat with, you could now use your gills to breathe the oxygen in the water. This is the way modern fish arose. During the summer, some swamps and lakes dried up, so some fish evolved a primitive lung to breathe air until the rains came. Their brains were getting bigger. If the rains didn't come, it was handy to be able to pull yourself along to the next swamp. That was a very important adaptation. first amphibians evolved, still with a fish-like tail. Amphibians, like fish, laid their eggs in water where they were easily eaten. But then a splendid new invention came along, the hard-shelled egg laid on the land where there were as yet no predators. Reptiles and turtles. Go back to those days. Many of the reptiles hatched on land never returned to the waters. Some became the dinosaurs. One line of dinosaurs developed feathers useful for short flights. Today, the only living descendants of the dinosaurs are the birds.
Chicken!
The great dinosaurs evolved along another branch. Some were the largest flesh eaters ever to walk the land. But 65 million years ago, they all mysteriously perished. Meanwhile, the forerunners of the dinosaurs were also evolving in a different direction. Small, scurrying creatures, with the young growing inside the mother's body. After the extinction of the dinosaurs, many different forms developed. The young were very immature at birth. In the marsupials, the wombat, for example, and in the mammals. The young had to be taught how to survive. The brain grew larger still. Something like a shrew was the ancestor of all the mammals. One line took to the trees, developing dexterity, stereovision, larger brains, and a curiosity about their environment. Some became baboons, but that's not the line to us. Apes and humans have a recent common ancestor. Bone for bone, muscle for muscle, molecule for molecule. There are almost no important differences between apes and humans. Unlike the chimpanzee, our ancestors walked upright, freeing their hands to poke and fix and experiment. We got smarter. We began to talk. Many collateral branches of the human family became extinct in the last few million
I'm just
years.
pressing buttons on it now. There you go.
With our brains in our hands, are the survivors. There's an unbroken thread that stretches from those first cells to us. Let's look at it again, compressing 4 billion years of evolution into 40 seconds. Those are some of the things that molecules do, given 4 billion years of evolution. We sometimes represent evolution as the ever-branching ramifications of some original trunk, each branch pruned and clipped by natural selection. Every plant and animal alive today has a history as ancient and illustrious as ours. Humans stand on one branch. But now, we affect the future of every branch of this 4 billion-year-old tree. How lovely trees are. The human species grew up in and around them. We have a natural affinity for trees. Trees photosynthesize. They harvest sunlight. They compete for the sun's favors. Look at those two trees over there, pushing and shoving for sunlight, but with grace and astonishing slowness. There are so many plants on the earth that there's a danger of thinking them trivial, of losing sight of the subtlety and efficiency of their design. They are great and beautiful machines, powered by sun source to go about its planty business. And we animals who are ultimately parasites on the plants, we steal the carbohydrates so we can go about our business. In eating the plants and their fruits, we combine the carbohydrates with oxygen, which as a result of breathing we've dissolved in our blood. From this chemical reaction, we extract the energy which makes us go. In the process, we exhale carbon dioxide into the atmosphere, which the plants then use to make more carbohydrates. What a marvelous cooperative arrangement. Plants and animals each using the other's waste gases. The whole cycle powered by abundant sunlight. But there would be carbon dioxide in the air, even if there were no animals. We need the plants much more than they need us.
Frankly, they don't. The surface is still too dangerous for life to truly thrive. That's why what we do here is so important.
Among the organisms of the earth. Some are very apparent, such as the use of the number 5. Humans have 5 major bodily projections: 1 head, 2 arms, 2 legs. So do ducks, although the functions of their bodily projections are not quite the same. An octopus or a centipede has a different plan, and a being from another planet might be much.
It's an honor to have you here, sir.
These family resemblances
Hi.
continue, and on a much
Isn't it wonderful here?
when we go to the molecular basis of life.
Hi there.
I've heard stories, and the surface sure sounds.
Different kinds of organic molecules, yet only about 50 of them are used in the essential machinery of life. The same 50 employed over and
Sounds
over again,
scary.
ingenious for different functions in every living thing. And when they go to the very kernel of life,
Greetings.
to the
As the Institute's requisition vendor, I can provide supplies for your missions on the surface. How may I assist you today?
essence which carry the hereditary information.
Sure.
We find these molecules to be absolutely identical in all plants
Hey.
and animals.
Requisition clearance granted. How may I help you?
I'll take a look. Sure.
This oak tree and me, we're made of the same stuff. If you go back far enough, you'll find that we have a common ancestor. That's why our chemistry is so alike. Let's take a trip to examine this common basis of life. A voyage to investigate the molecular machinery at the...
Hey, where'd my video go? ¿Eso está jugando? ¿Está jugando? Oh, I'll be right there.
This is the first moment in human history when we have explored any other world for life. We are just beginning. Would you love to please Dr. Carl Sagan?
He's almost sure like the best known scientist on the planet.
Cosmos is a Greek word for the order of the universe.
He takes the genuine intellectual experience and lifts it up and says, "Ah, isn't this great? Don't you feel wonderful? How can you live without this?"
The universe now newly created,
I wish when someone stopped telling us.
billions of years from now, be utterly destroyed. 8.64 billion years long. 10 billion atoms.
His greatest service has been his ability to humanize science and make science accessible and thrilling to the masses. He's often said, when you're in love, you want to tell the world about it. That's what science is for him.
Stupid
He created
stories.
his own work, imagined it, created it, and went into it. He is his image of what he
We should get out of here as soon as we can.
We think that this may be a beacon, a sort of announcement to kind of get our attention.
You're sending this message all over the world.
In 1996, Jodie Foster and director Robert Zemeckis started shooting Contact, a film based on the novel by Carl Sagan.
I'm glad to see the relay.
Excellent. For Sagan to spread
Didn't
his
completely vaporize you.
The interceptor worked.
popularized
It was
science than
amazing.
anyone on the planet. He's been called a visionary, an activist, and occasionally a grandstander. But to hundreds of millions of television viewers worldwide,
I can't find it anywhere. I'm sorry.
What? No. Volkert. Damn it. What am I gonna do?
We're going to explore the cosmos in a ship of the imagination. Come with me.
What about the virus? Won't your condition get worse over time?
Scientist in a career on the same trajectory as NASA itself. He's been on board for 30 years.
Then end it now, while you can still make that choice.
I don't think I can.
His combination of hard science and soft cell has won him a Pulitzer, a Grammy, and 3 Emmys, but never a Nobel.
Wish I had a gas
He's
mask.
risked his reputation as a scientist too
Holy
long,
shit, this is dark.
driven by the same controversial questions since he was a tiny boy. In a small corner of the cosmos in the Bensonhurst section of Brooklyn, New York, Rachel and Samuel Sagan had found each other.
I think that's all of them.
My father and mother had an unusually close and loving
Sagan was a worker in a garment factory, a Jewish immigrant from Russia, working hard to get ahead in the Depression.
Rachel was the intellectual, Sam was the businessman. He was very good at what he
This is
did.
fucking dark.
Managed to do well during the Depression.
Can't do that to Virgil.
November 9th,
Got it right here.
That's it. That's really it.
welcomed a
All
son
right.
into their
Let's see. Let's see.
What is that smell?
Retrovirus has matured nicely. Density gradient is high. Recombinant counter-intron sequences look stable. Transcriptive exon strands have formed.
Rose and set on her son.
That's good.
It is.
Watched over him. She was very concerned that he fulfilled his potential. She was a natural
Protect
student. She
and
passed
serve.
this on to Carl.
When Carl was 4, his parents took him 1,000,000 miles from the Depression and from Brooklyn for the 1939 World's Fair.
All right. Here we go.
Carl was captivated by this wonderful
No.
vision of the future,
We wait.
ordered by science, where
It'll work.
everything was streamlined
I hope so.
and no one was
I'm going to rest for a while. I'm back in any event.
dreams of lights in the sky, more than just fireworks.
Virgil?
He was
I'm going to get
always
some rest.
of stars.
We just have to wait.
Mother took Carl to New York Public Library because he wanted to learn about stars. And he must have been 7 or 8.
Protect
He went up
and
to
serve.
a librarian and asked, can she find him a book how to see the stars? And she said, sure, Sonny, just a minute, I'll be back. She came back with a book about Clark Gable, Greta Garbo, Hollywood stars.
When he finally conveyed what he was after, Carl read an entire book on astronomy in one sitting. In a big bang of consciousness, the scale of the universe opened up for him. If the stars are distant suns, they may have other planets. Planets teeming with life.
The possibility of there might be life elsewhere charmed him and excited him at a very young age.
Another kind of book fired his imagination as well. Science fiction.
The wildly romantic Mars novels of Edgar Rice Burroughs took Carl to Barsoom, as Mars was known to its inhabitants. On imaginary journeys with his hero John Carter, Carl rode 8-legged Thoths, befriended a 10-foot green giant, and won the hand of the Princess of
You're gonna
Helium.
pick up a serious blow sticking around here.
John Carter got to Barsoom by standing in an open field, spreading his hands, wishing hard. I can remember spending many an hour in my boyhood, arms resolutely outstretched in an open field, twilight, imploring what I believed to be Mars to transport me there. Never worked. There had to be some better way.
Maybe rockets. Toward the end of the Second World
Dog meat.
War, Carl heard about the V-2 rockets that the Germans
Everything
used to
okay,
bomb
boy?
England. That gave him some ideas.
Don't worry, dog meat. Just saying hello.
He was interested in astronomy. He thought that there were probably little men on Mars.
Nothing stays hidden forever.
And he thought, even at age 11,
Not if I have my
that
say.
by the time the space age came about, he'd be too
Did the
old
Minutemen
to be
send
an
you?
astronaut. But he wanted
Yes,
to
I'm here to help.
There's a group of raiders. We know where they're coming.
Kind of astronomer
Don't worry.
who studied
I'll take care of those.
I hope so.
connections with the people out there. The
What's going on?
When Carl was 13, Sam
Here's that holotape you gave me, full of Institute data. I hope.
Well, all right. I'll start digging into this and see if...
Rahway High School.
We've been having some
Carl
trouble
was an
with grades.
overachiever.
That's exactly what the Minutemen are
Class
for.
brains and most likely to succeed. As Carl's high school
What do you
year
hope to find?
Whatever the Institute doesn't want anybody... all the good stuff on here is going to be encrypted.
He should achieve
After that, well, I'll have to see what I've got.
Carl accepted
There's no telling...
Holy shit. Holy shit. Jackpot! Woo! Oh my god, 2,000 points! That's excitement. That is full-on level of excitement.
As captain, he led his intramural basketball team to university-wide victory.
Carl's major attribute as a basketball player is he was a terrific rebounder. A very aggressive and energetic rebounder. He was known for the sharpness of his elbows under the backboard.
Carl was as aggressive in advancing his career as a scientist. He talked his way into a summer job in the lab of Nobel laureate H.J. Muller. Muller was working on the origin of life on this planet and possibly others. Sagan was hoping to work with Muller on the big question. But Muller had the eager young... Sagan tend his fruit flies.
I think he began to develop
Can we trade a few things?
appreciation that there's a lot of science that's hard work. On top of the great intuitive leaps, there's a lot
Hey.
of slogging through the data and doing all of those things.
Carl stayed at the University of Chicago to study for his doctorate in astronomy and astrophysics under another mentor, Dr. Gerard Kuiper. Kuiper was a maverick astronomer who studied planets and the possibility of life on other worlds.
Nearby. We're having problems with raiders nearby.
Most mainstream astronomers prudently avoided.
Raiders that are nearby.
Science.
Raiders are nearby.
Something was discovered in outer space that changed everything. It was Sputnik, the first man-made satellite sent up by the Russians.
Alright, switching over to Battlefront. See you guys later.
Off the ground, Carl made his own giant step.